Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Trigonometric Graphs. Question 7. Y is equivalent to the inverse cosine of x. To inquire about pricing and ordering for this complete cram session, inbox me at memedicine@gmail.com and be sure to spread the word to your classmates and colleagues or whoever is in need of cramming for Algebra 2 as well as trigonometry. All right, let's delve into this problem together. Review question 7. Sketch the graph of y is equivalent to the inverse cosine of x. Definitely press pause and I'll give you a moment to think. And when I say think, what I mean is press pause and figure out a solution and then sketch your graph from your reasoning, okay? All right, so hopefully by now you are able to press pause and come up with a concise graph. But if you weren't, that's completely fine. We're going to do this together. Now, what I'm going to do in order to arrive at a concise graph is I'm going to go back and forth in my reasoning and kind of work backwards. So I'm not trying to confuse you, okay? So just bear with me. So something that I need you to recall or remember or just learn now if you've never known this is that the range for the inverse cosine of x is 0 to pi. So x is between 0, for y, not x. Y is between 0 and pi, okay? So 0 to pi. All right? So that's just something that I need you to bear in mind. And what you need to also know is the definition of range for a better understanding. The range is a set of all possible values for the dependent variable, and the dependent variable, as previously insinuated, is usually referred to as y. All right, so y is usually our variable for our dependent variable. Then what I want you to do now is make a table, okay, of values for y equals the cosine of x rather than y equals the inverse cosine of x. And you're going to make the previously mentioned domain, the previously mentioned range for the inverse cosine of x, you're going to make that your domain, okay? And the domain of the function is the set of all possible x values for that particular function. Again, it's the set of all possible x values or independent variables, rather. It's like the input, what you choose to input into the function. And it's usually expressed as x, okay? It's going to go on the horizontal axis. So let's just represent that now. We have 0, because remember I previously mentioned that the range for the inverse cosine of x starts at 0. Okay, and what I also want you to know is that it's going to be convenient to rewrite all the x values with the same denominator. But let's just load this table up and then do just that. So then you have pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And now what we want to do is to neaten things up, give all of these independent variables the same denominator. So that's going to be 2 pi over 12, 3 pi over 12, 4 pi over 12, 6 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, and 12 pi over 12. Okay? All right. So what we're going to do now is find out what the cosine of these angle measurements are. So let's just load our table. You should know this on your own. And in order to figure this out using your calculator, make sure you set it to degree mode. Okay, I'm going to show you how to get to degree mode, radian mode. I'm going to show you how to get there a little bit later. So the cosine of 0, you should know, is 1. And dot, 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 0.87, 0.71, 0.5, 0, negative 0.5, negative 0.71, negative 0.87, and negative 1. Okay, you should see a pattern here with the point of inflection being 0. Okay. Alrighty then. All right, so since the inverse cosine of x is the inverse of the graph of cosine of x, this is the part that gets a little back and forth and confusing conceptually. What we're going to do now basically is reverse all the coordinates, okay, of all the points in the table for cosine of x. So where we have our first set of data points, our independent variable is the angle measurement 0, and our dependent variable is the cosine. We're going to just switch them. Okay, so the independent variable then becomes the cosine of x, and the dependent variable is the angle measurement. So this should just put you on alert that whenever you're trying to find an inverse, the answer to an inverse function, you're actually going to always end up with a angle measurement, okay, whether in degrees or radians. So after you do all that, this is what your graph should look like. The input is going to be the cosine, and the output is going to be the inverse cosine of x, or the angle measurement, okay? The angle measurement that corresponds to its specific cosine value. I hope I didn't trip you up too much. If I did, sorry. But another good thing is that you can use your calculator to solve this, okay? Or you can use your calculator to check your work, rather. So let's see how this is done. And the calculators that I'll be referring to is the TI series, either 83, 84, and even more advanced models. The keys should be very similar. And if you're using another brand of graphing calculator, the concept should be similar. It's just that your calculator might have a key labeled differently or located in a different place, and the screen settings might be labeled a little differently as well, okay? All right, so let's simulate our calculator check, okay? So the first thing that we're going to do is ensure we're in radian mode. By hitting mode, this screen will pop up, and then the cursor will automatically be flickering over normal, okay? So press the down arrow once so that the cursor is flickering over float, and then press it once more so that it becomes positioned over radians and it's flickering there. And because this line is set to degrees, what you're going to do is hit the left arrow, okay? And then you don't have to press enter. All you're going to do is press second mode to quit this screen. Now what we're going to try to do is input the inverse cosine of x, okay? And you do that by pressing y equals, then this screen will pop up. Now you have to populate line 1 with a function. So all you're going to do is press second cosine, and these are the keys that will pull up the inverse cosine function, which comes preloaded with an open parentheses. Then you hit your variable button, xt theta n. Okay, it's usually set to x, so x will be the variable to populate the screen, and then you shut off this function with a closed parentheses, okay? And now what you're going to do is simply hit graph. By hitting the graph button, this screen will pop up a graph of the function that you just entered in your y equals window. But a better viewing setting for inverse trigonometric functions. Note I said inverse, not reciprocal. Reciprocal is like cosecant, which is the inverse of sine, or secant, which is the inverse of cosine. I'm talking about the inverse functions that yield angles as answers, okay? So a better setting for that is going to be ZoomDecimal. and you get that viewing window by pressing Zoom and 4, that's the decimal setting. And so you'll get something like this, okay? All right. Actually, I think this is reverse. This is what pops up when you hit grab, and this is what should pop up when you hit zoom for. You notice the difference, right? Okay. So what I want to caution you to do or to study is to know the graphs of the basic functions. Know what they look like so you can determine if your calculator is representing them well. And just in case you're unsure, using the table feature by hitting second graph, okay, it'll be able to show you the independent and dependent variables, all right? Notice that because I said earlier on the previous page that the extent of the inverse cosine range is -1 on the lower end. And then I think, I don't know, you know what I'm trying to say. It doesn't hit these values, okay? All right, so yeah, that's about it. Actually, no, what I was saying, we reverse things, but you know what, forget it. Just let's leave it at this. Okay, all right. So yeah, pulling up the table will allow you to view the independent and dependent variable values of the illustrated inverse cosine function, okay? All right.